Hi, folks. Hello. Good morning, good evening, good afternoon, good middle of the night, depending on where y'all are joining us from. Hi, I'm Anjana here in San Francisco, and joining me today is Ian. Want to say a quick hi to
Hello.
everybody?
Yeah.
Hello. We are really excited to be back here on the stream with y'all. Would love to know who all is here in the chat. Let us know where you're coming in from through the interwebs. Um, and yeah, I hope you all are excited to talk more about D3 today because we are going to be doing some mapping in D3, which I'm pretty excited about because maps are really cool. And Ian is going to be leading us through some air quality data visualization. I'm going to ask you to tell us a little bit more about that in a second, Ian. But suffice it to say that it's very apropos. It's very on our minds, air quality data, since we're coming at you from California today. Um, Quick reminder: we are in a learning, positive, inclusive, supportive space governed by the Observable Code of Conduct. So please don't forget to check that out and remember that we're all agreeing to abide by that in our chat. But I think that is all of our business to take care of before we jump in. So Ian, tell us a little bit about what we're going to be doing today. What's up with this air quality data?
Yeah. So, as many folks are probably aware, there's been these awful wildfires all over the state of California. And of course, they're putting a bunch of smoke into the air and making it so bad in some days and some times where you really shouldn't go outside. And I found out about um, I guess it's a platform, it's a website, PurpleAir, that shows a bunch of sensors. I guess people install these kits that monitor the air quality, um, where they are, and then they upload the data to this site. Um, and so you can get a sense. It's like a lot more detailed data than the official government air quality monitors, which only have like 4 or 5 in the Bay Area. So this actually has like thousands all over the state. And yeah, you'll see here. The thing is, so I was checking this every morning or all the time, trying to keep tabs on what the air quality was like. And I have some experience in mapping earlier in my career, and doing a lot of D3 based data visualization. I thought I wanted to look at this a little bit differently than is being shown. Namely, you'll see in a second when all the data points load that there's a lot of them. They're sort of heavily clustered in the urban areas, and there's a lot of overlapping points. So I wanted to try some, more or less, I guess, standard visualization techniques to get a different view. And I also wanted to see how it changed over time.
Yeah. So this
Yeah.
is so we're just
Mm-hmm.
looking at this is and I've been using this too to check on the air quality in the city. This is purpleair.com. And they have this map where we're basically seeing like one data point per sensor. Is that right?
That's right.
And then it looks like they have like some are inside, which I'm not sure what that tells
Yeah.
us.
I
But
mean,
so I'm gonna uncheck that. And so what we're looking at is like the outdoor air quality, which as you can see is in the it's in the red zone. At least it's not kind of purplish right now. So there's that.
yeah.
But you're saying so this is like we're basically seeing one dot per sensor, and they're kind of clustered in not necessarily the most fun, useful way. And we also don't, we just have right now, or I guess we're looking at the 10-minute average, but we can't see how this plays out over time. Okay, so we're going to try to make our own map from this data, displaying it in a slightly different way, and we're going to try to add time to that data. Is that right? Is that what we're going to do?
Yeah, I think that's a good goal.
Okay, cool. I'm stoked. I hope you all are stoked. Joining us in the chat from all over the place. We got Massachusetts. We got more folks in California, San Francisco, LA. I don't know how things are down south. We can check the map later. And we actually already have a question in the chat. Curran asks, what solution did we end up going with for the cron-like job? And I'm guessing that's related to the data processing that we need to do to see this, to get this data into a format that we need. which maybe
That's right.
we can talk about a little bit later? Or do you
Yeah,
want to
yeah. I
address right
think,
now?
well, it may, we're probably the next step will be looking at the data that we'll be using, right? Um, or or we can talk about it a little more detail when we get to that step. Were you thinking we would start a notebook now, or how do you want to?
Yeah, let's jump into this notebook. Um, and I just want to make sure folks can see everything on our screen okay. I feel like I'm having a little bit of a video issues today. Is everybody able to read the screen, the notebook, the mapping air quality data? Hopefully. If you're not, let me know. So we're working in this notebook. Right now we've got a notebook that's because you and I, Ian, are in this observable team, we've got like a team notebook that we can both edit. But great, folks can see it, wonderful. But great, so why don't we try something a little new this time on the stream? If we publish this notebook as we go, then folks won't be able to see real time what we're editing in the notebook, but they will be able to like edit along with us. Is that right?
That's right. That's right.
Okay,
And
so
so, yeah.
yeah, go ahead. Sorry.
Oh, well, I think it'll be interesting because, maybe every time we make a bit of progress, we could publish again. And then if that gives some folks an idea, they could fork it at that point or play around with it as we have it and let us know in the chat. Share the forks in the chat, for example.
Okay, great. So let's publish this live on air, publishing things. I'm going to grab the URL right here and plunk it in this chat. This is where we'll be working. And great, thanks everybody for the feedback that y'all can see it now. Glad it's going smoother. Yeah, video encoding is hard, huh? Anyway, okay, so now what y'all are looking at is going to stay looking like it does right now. But meanwhile, Ian and I can go through and add some more cells. And whenever we get to a logical republishing point, we'll republish so you can sort of catch up. But don't forget that at any point you can fork this notebook and make it your own. All right, so where should we start, Ian?
Well, I think, probably a good place to start would be the data, right? Like we can get the data from. Well, I should maybe mention that I've done a few visualizations around this data set.
Okay.
Right, that we
so
can.
I've seen. This is kind of what I've been using as sort of a reference. Is this the right notebook?
Yeah.
Great.
Yeah.
So
I think this will be a good thing to sort of aim for being able to reproduce today.
Okay, so just plunked that in the chat too. And so how did you get this data into the notebook from PurpleAir?
Yeah, and so this is where I get to answer Karen's question about the cron job.
Great.
I basically developed a set of node scripts to query the PurpleAir API and get a list of all the sensors. For each sensor, download their historical data. This notebook you just pulled up is kind of like my scratch pad that I ended up publishing this in case people were interested in this whole process, where I figured out how to access their API, what comes back, and like the API for downloading the actual historical data. So what I think we can do though is take the results of that script, which actually, to answer Karen's question, honestly, I haven't figured out a cron solution for it. Like I had posted on Twitter a few days ago, to get ideas, the easiest way to like run this script on, a regular basis without necessarily having to manage my own server. So I'm still open to suggestions from anyone in the chat on doing that. But in any case, what I've done is I just run it, every morning and every evening or so, and then upload the resulting CSV to the notebook, to the Mapbox visualization. So
so you've got another one, which hopefully at some point we'll talk about mapping with Mapbox. Today we're going to focus on mapping with D3, but you've got another version using Mapbox for these maps. This one here.
That's right. Yeah.
So if folks are interested in taking a look at that, they can take a little dive through there and stay tuned for hopefully some more mapping on the stream in the future. But okay,
Yeah.
so for the purposes of this, I think that so processing this data is a whole subject in and of itself, which we could easily spend an hour talking about, right? Like, no problem. But it seems like maybe for the sake of getting into the mapping today, should we just start with some sort of process data that you've already got that we can, like, perhaps on a future stream, we can dig into more of the pre-processing part of that and how these scripts are working. And
Absolutely.
but for now, we can just go with what you've got already.
Absolutely. So
Cool.
I would, the place I upload the CSV and sort of as my main distribution is the Mapbox notebook.
Okay, cool. So this is in their file attachments here?
That's right. Yeah.
Great. And let me just make this a little bigger. So this is something cool about file attachments is that I can see the files that you're using on whatever notebooks you have. So I'm guessing it's this one and not any of the unused files. So this one at the top here looks to be the one that you're using in the Mapbox notebook. I can just download it right from here, can't I? Should I do that and then re-upload it to our notebook as an attachment?
Yeah, I think that's perfectly reasonable.
Okay, cool. So I'm just going to download that here. I'm going to go over to our notebook. I'm going to make a new file attachment. So I'm going to go to the notebook menu at the top. There's 3 dots here and go to file attachments. And that's where I can upload. And I'm just going to select this last one that I just downloaded. Thinking about it. And voila, there it is. And now if I go over to my little file attachment menu here and copy this, I can get let's say the text of that file out. Okay, cool.
That's right.
All right, so that's one way I could do this, is I can like download the file and then re-upload it as an attachment. Somebody asks a great question in chat. Karin asks, can't you import file attachments across notebooks? Great question, Karin. So you can't import, and correct me if I'm wrong, anybody from the team on the chat, but you can't import the file per se, but I could import this data since your notebook where you have this data is public, I should be able to import the data itself as a cell from your notebook. Is that right?
That's right.
Okay, so let's see. Which one are we looking at here? It looks like you've called it hex data. Things are loading and it's pushing my cells around here, but it looks like this hex data cell is going to be the one that I want, which is already parsed and typed and whatnot. So if we have, in this situation, we have like, we're doing a very similar thing. We maybe just want the data in exactly the same format and like with all of the CSV parsing and everything that you've done, and I don't need the raw data file itself. So this actually could be a really good solution. I can import the hex data cell from whatever your notebook is called. Let's find it. Anjana PurpleAir Historical Data. Okay, so let's try it that way. So now so this is one option. But instead of doing that, let's try it up here. I'm going to do import hexbin, right? From Anjana PurpleAir Historical Data. And now I should be able to get hexbin in a new cell, and it's a function. Is that right? Did I?
Oh, no, sorry. It's hex data, not hex.
Oh, hex data. Oh, sorry.
Yeah.
That'll do it. And now, there we go. Look at that. Yeah. 300,000 data points. Let's check it out. And all nicely parsed.
The nice thing about this too is that when I update the data in that other notebook, then and I publish that, then your notebook would get the updated data.
Great, cool. Okay, so I think this makes more sense to do than the file attachment way for this particular project. So I'm just going to delete this. Does that make sense?
Yeah.
Cool. But just so folks know, for other cases, you might want to get that actual like data file itself, and you can work with that offline. You can process it on your own, outside of Observable, whatever, and then use the file attachment downloading to get access to files like that. But in this case, let's do the import. Great call, Curran. Okay, so now we've got some data. What do we do with it?
Yeah, so I mean, we'll take a second just to explain what's in it.
Great.
So we have latitude and longitude coordinates for each point. So that's what's going to let us put the data on a map. And this data has already been pre-processed to, that's why it's called hex data. Like I ran it through a hex bin so I could take the median air quality data value for like a small region on the map, so that instead of having all the dots overlapping, it's just like, okay, it puts a regular grid. That's why it looks like a regular grid here.
Right. So these little hexagons, these are like all of the sensors from the PurpleAir map within, don't know what happened here, but within a particular hexagon on the map.
Exactly.
Okay, great.
Right. So those coordinates are going to be like regular on a regular grid like that, and then there's two air quality indicator values. The PM1 is the sort of the thing that you mostly want to pay attention to, like the big particles that are unhealthy. But I also included P03, which is like, I think, a measurement of particles ranging from like very small to big, so that like that number, if that number is really high, doesn't necessarily mean unhealthy, but I basically included it because I noticed sometimes the PM1 would be like healthy and green, but you go outside, it still smell like smoke and like not be comfortable, and you'd see that the P03 number is still high. So
interesting.
And that, I think there's a challenge that came about too on when I originally tweeted some of these explorations. People were like, I'd like to see both of those at the same time, and that's an interesting viz challenge I don't think we'll get to tackle today, but I think if folks are interested in that, it'll be set up to experiment with it after today's stream.
Great. Okay, awesome. Okay, so now that we've got the data in, let me maybe republish this, perhaps. I'm just gonna so folks can play with it. Okay, so that's been republished. If y'all reload the notebook, you'll get the new version.
The last field I should call out is this day field, which really should probably be called hour or time. I don't know, but it's essentially a timestamp, and it's going to be an sort of even increment. So for every hour, there will be a bunch of values at one for the whole grid. So that's where the time comes in. Basically, if we say like, I want to plot all the sensor data I have, on August 30th at noon, right? Like, or you want to play it back to make the animation, you can get the time value.
Okay, so this is day in or this time seconds, is in seconds. Okay, but it basically maps to like a particular hour on a particular date.
That's right.
Okay, cool. Great. All right. So now we have a sort of, at least I have a somewhat vague understanding of what we are looking at here. And what we're going to want to do is we're going to, like, I think maybe a good starting point would, if we can just map one of these hours with like the snapshot in time of how things look. So sort of like the original PurpleAir map does. I would already feel accomplished having drawn some air quality on a map. So let's maybe try to start there, shall we?
Yeah.
Cool. Great. So how do we map with D3? How's that going to work?
Well, there's a very handy module called D3Geo.
Okay.
I mean, this is, again, gets kind of like the scatter plot that we did last stream. We're going to go a level slightly deeper than you would with most mapping libraries like Google Maps or Mapbox, but it means that we can like build a lot of cool stuff from scratch. So we're gonna have to like
Okay.
get a little bit into what are called projections, which thankfully D3Geo makes pretty convenient once you know how to use them.
Okay, cool. So I'm just gonna start to organize us a little bit here. I'm gonna add some sections. Let's do D3 map. Okay, so D3Geo is what we're gonna want here, yeah?
Yeah, we could just include all of D3, I think. And,
Okay.
that would be helpful.
So I'm just gonna require D3. Cool. And then from D3Geo, I get things like, I get all these geo-albers, geo-azimuthal, geo-centroid,
Yeah.
etc. These are all these like different projections and things, which if I want to read more about those, what do I go to the D3Geo docs, is that right?
Yeah, I mean, a Google search for D3-Geo would bring up the docs as well as probably some.
Okay.
I mean, there's like a ton of examples on Observable as well.
Okay. Cool.
And
So
those will
I'm
be
just gonna
linked. Yeah.
drop this link in here. Oh, nice. We've got a fun discussion going on in chat about how to name longitude, lon, lat, lung, ling, lung. I don't know. That again, we could spend an hour discussing. So yeah, so we've got the D3Geo repo. Just drop the link in the Slack in the chat, and there's also in the D3 gallery on Observable. There's like a whole section of map based visualization, so which go way into in depth onto different things you can do with maps here. So I'm just going to grab the link to that. Okay, so.
And I think this goes to the point of, this goes to the point for sure of like, if you can get maps going in D3, like the range of possibilities is huge and like really exciting. So,
Indeed.
We'll start with simple, like drawing circles on a map, correctly in somewhere in the world. And then from there, you can do all kinds of stuff.
Okay. Maya has a question, which there are no dumb questions. We do not have any dumb questions because there's no such thing. About how we are going to set the kind of width and height of the map, like we do sort of the domain and range of a simpler scatter plot or something like that. So I'm guessing we're going to figure that out as we go through and draw this map. So maybe we can just make sure to come back to that question as we go. Thanks for the great question.
Yeah, no, it's a really good question because it gets to the heart actually of the next step that we'll do, which is to set up a projection.
Okay.
And so, yeah, I mean, if you do that D3.geo autocomplete, right, where it shows you a list of things, some of those are utility functions like centroid or bounds, and some of them with the weird names like albers and azimuthal, those are projections.
Okay.
And the projection probably most people are aware of is Mercator, right? Like that's what Google Maps and all those things are usually rendered in. But it is, often regarded as a less than ideal projection because it distorts areas a lot. So, there's all kinds of history behind like, navigating the seas hundreds of years ago or something behind that. But so I'm going to suggest that we go with GeoAlbers USA.
Okie doke. This one here.
That's right.
Autocomplete. Okay.
And so what you'll want to do is call this like a function because it's going to generate, sort of to get towards the answer to Maya's question. This is going to create something akin to a scale. It's like we want to basically pass this function a latitude and a longitude, or maybe it's a longitude and latitude. That's another thing. People talk about the names. Wait till you get into the whole debate about what order they should
Ordering.
be in. Yeah.
Indeed.
So yeah, you want to basically pass in a longitude latitude point and get back an XY coordinate that you can plot on the screen, right? Just like our scale.
Yeah, so this is sort of like when on our previous stream we made like a function that converted one of our data points with values like in whatever domain of values we had and converted it into like an x coordinate on our plot. Is that so? And
That's
this is
right.
doing a similar thing. It's just we're using a geographic projection instead of the kind of XY axis projection. Sort of?
This is correct.
Okay.
So
Just checking.
so yeah, no. So basically the question is going to be, instead of domains and ranges, what do we how do we configure this to like tell it we want to make it, you know, a map that's 900 by 600 pixels, and you know how to zoom. You know, the next major question will be zooming in and like panning around, right?
All of that stuff. Okay. But even if we could just draw like a map of one place on the screen, I'd be happy. I would feel like we did something cool. So can we how do we take this projection function and draw something with it?
Yeah, so let's just start by giving it a name, like saying projection equals this.
Boom. Named.
Yes. Yeah.
Feels so powerful. Can name whatever I want.
The other thing that we'll want to do is create, you know, a chart, like a SVG canvas like we did for the scatter plot that we can draw into.
Okay, so we could call this SVG, I suppose. And is this just going to be, what do I need in here?
Well, you can just give it the width and height. So one thing I often end up doing is defining a height variable that I'll use in my notebook to.
Okay. What's a good value, like 400 or?
Yeah, probably 400 so it doesn't take up too much of the screen while we're streaming.
We can adjust that as we go. Okay, and so now I want to make an SVG with, I just set the attributes right here. Is that right? Or do I need to put it in a style?
Yeah, you can interpolate. Yeah, for SVG, you can set the width and height directly.
Okay, cool. So I'm gonna use my little, I'm using the built-in observable SVG template tag, which is sort of similar to HTML and Markdown or MD. Since I'm using this with a JavaScript template literal, I can use my $curlies to put in my built-in my built-in width value, which Observable just gives me for free, and then the height value from the cell above. And I guess I should close this. Okay, so I have an SVG of a certain height. And if I change this, the height changes. Cool. Okay.
Yeah.
Oh, thanks for dropping the link. Yep.
Yeah. So yeah, I think the next step would basically be setting up a render function like we did last time that's going to hold our D3 code that will do the actual drawing of our map.
Okay, let me make sure to name this. I'm going to call this SVG. Oops, circular definition. Oh, I renamed map SVG. How's that? Okay, and we want a render function. And this is going to take our SVG, I'm guessing?
That's right.
Okay, and we're going to fill this in.
Mm-hmm.
Cool.
And then we'll also want to, in another cell, call the function so that we know that it'll actually render.
Okay. We called it. It's not doing anything yet. But
right.
If I do return hi, it works. Okay. All right. So if we want to draw something on our map projection, I feel like we're going to need more than just the projection function, right? We're going to need like something to draw, like some data that we want to run the projection function on. to put it on a map?
Yeah, so there's kind of two ways we could go, because and it takes us down slightly different paths to get to the same place. One is we could just try to render our points as they are, because we have that long. We can run them through the projection and just see them show up on the screen.
Yeah, let's do that.
All right, let's do that. Because the other one would be, I'll just because we're gonna get to this right afterwards. Is to load in some like state boundaries, right? So we can get California and have some context for our map, which is something you almost always
The base map,
do
basically, like
yeah,
like a kind of reference map underneath the data that we actually care about.
That's right.
Okay, well, let's see if we can just draw some dots, and then
Yeah.
maybe we can put the base map on to make them make sense. Not that I wouldn't love to just memorize the outline of California or something so that I can look at some random data plots and know what they correspond to. So, okay.
Yeah.
And Mutari points out that when I accidentally renamed the SVG built-in function, I tried to rename a cell or name a cell SVG, and it didn't like that because I was trying to reference the SVG built-in. That's a common thing. So since we have sort of built-ins in Observable, if you use those names like MD or HTML as cell names, then you kind of lose access to those built-ins. So it's useful to consult the standard library and the user manual and stuff like that. Great point. Okay, let's draw some dots, shall we?
Yeah, let's do it. So
All right.
yeah, I mean, we'll use D3 to select the SVG.
Okay. So I'm going to do something like let SVG equal D3 select. Is it just SVG? Is it that? Or no, do I pass it?
Yeah, we want to pass in,
Right.
because the SVG template thing is a DOM node, right? Like that's what it gives back.
Okay.
So we want to use D3 to select that DOM node, and then we're going to use D3's join stuff to make a bunch of circles.
Okay. So
now, yeah.
if I return, just to check here, just as like a little check. Oh, render is not defined. What? Oh, SV. I did it again. I'm going to pass in this SVG element. Or sorry, no, this is a node. What should I call this? Map SVG again.
Yeah.
This is too much overloading. I don't like this. Let's do SVG select. Selection?
Yeah,
okay, great.
Selection, yeah.
I like to be explicit. I don't know. Again, naming, we could talk about it till the cows come home, but it's nice to know what we're talking about. And here we're talking not about the SVG element itself, but like the selection, the D3 concept, which is this weird structure here. Okay, just checking.
Yeah.
Okay, so it seems like folks are experiencing a delay for the chat in the stream. There would be a little bit of delay. I think we have enabled a slight delay for moderation purposes, but hopefully you'll see things catch up as it goes. It could also be that we're experiencing some problems with latency, but hopefully we can just deal with those 15 seconds. Sorry about that. Okay, so now that we've got our selection, let's join some data to it. Can you navigate me through that?
Absolutely. So yeah, let's do svg.selection, and then we'll select all, and we want to draw dots, so we'll select a bunch of circles.
Select all?
Yes.
Okay.
So the next, this line is going to be critical. So this is .data, and we're going to pass in our hex data.
Hex data.
Now, I recommend that we actually slice like the first, 100 or 1,000 elements, because remember that was like was it 300,000?
Yeah.
If we try to draw that many DOM elements, your browser is going to be very unhappy with you. So
I support us trying to keep my browser happy. Also, because the more unhappy my computer gets, the less good the AV of the stream gets. So, and, and yeah, sure, I'd be happy to share more about our setup in the future. So okay, so I'm going to select. Like, do we want to even maybe like filter to a particular time point or something outside of our? Like, would that be helpful?
Yeah. I think, well, I would recommend we just do the slice just so we could finish this
Okay.
thought of like
Okay.
seeing
Okay.
stuff.
Cool. Okay. So
And
let
then
me
we'll
just
come back and
slice. What do you have in mind here? Like,
I think
I always forget slice
1,000,
syntax. Can I just do? Do I have to do zero?
zero comma, yeah.
Is that right?
1,000.
Okay.
Yeah.
Somehow.
Yes.
Yeah.
So that'll give us the first 1,000 elements.
Cool. Okay. And then do we want to do like a join?
That's right.
Learning D3 here. Look at this. On circle.
Circle. Yeah.
See, that always confuses me, how we have to first select these circles, which don't actually exist yet in our SVG. There's nothing in there. And then say we want to join to more circles. I don't know
Yeah.
why that
Well,
confuses me a little bit, but I have to remember always that I need to pass it in that second
You're
time.
definitely not the only one. It's the selection that, or I guess sometimes called like the update, enter, update, exit pattern is like the biggest learning curve with D3. But as I think as we'll see, it kind of like, if you can get the hang of it, it's really powerful. But yeah,
Absolutely.
it's totally,
Yeah.
yeah.
It's just a power I can also use to burn myself. Okay, cool. Yeah. So as Mutari helpfully points out, this is like our target. Like what we're targeting with our data here is like circle elements. That data is going to go plunk into circle elements magically with the power of D3.
Yep. That's right.
Okay, cool.
So,
what else do I have to do?
yes,
I have to add some attributes to these circles?
That's right. Yeah. Yeah. Just like we did
Okay.
last time, we're going to set like a CX, a center X, and a CY.
Okay, let me, so this is probably going to be the lat long. So this is, okay, so just starting with the CX, we said each of the data points has a lat long, whatever we're calling them. And this projection function is what we're going to be using to figure out how we get from that lat long to a point on the SVG. And so I'm guessing that's what I need to be calling here.
Yes.
So do I need a little
Exactly.
function like each
You got
data
it.
point goes to, and I'm going to call GeoAlbers USA.
Oh
no,
well,
projection.
you just want to call it projection. Yeah.
Right,
since
we
you
already
said
renamed it.
that. Yeah.
Right. And so how do I have to structure this? Does it take an array?
It's an array with the longitude, comma, latitude in it.
Longitude, comma, latitude. So that's going to be d-lung, d-lat. Did I do that right?
Yes. And it's going to return an array of x, comma, y. So you'll want to grab the first element of that array.
Oh, okay.
That it returns.
0. Did I get the parens right there? I think so. Okay.
One thing I might suggest doing, I'm going to paste a longitude, latitude that should be centered on San Francisco into the Twitch chat. And we could just call projection on that pair in another cell just to see what's going on.
Sure. Let's do that. Okay. So I'm going to, in a new cell, this is probably going to break. Yeah, okay, because I didn't finish that. In a new cell, I'm going to call projection on this San Francisco and see what we get. And so we get an array of, these are now XY coordinates in the projection that I chose. And if I were to, let's say, change this to GeoMercator, the XY changes because the projection has changed.
Yep.
Cool. Okay, and there's so much more we could say about map projections. And somebody, I think earlier, really helpfully dropped in the reference to the really great XKCD panel about different map projections and what your favorite one says about you. So go check out that XKCD comic later if you want. Okay, but for now, I am convinced. You have convinced me that this is going to do what we want. So I'm going to replace the Y one with 1 here.
Mm-hmm.
And
then
yeah.
the last attribute we'll want to set for now would be the radius, which is just R.
And that we can just make that something constant, right? Like, what do you think?
I'd probably go with 5.
5. Okay. Is that it?
I think so.
Will we now get... Look, we have dots. We did it. We drew dots. Yay! Yay, we drew dots.
Nice.
So exciting.
What we've probably done is draw a lot of dots on top of each other. I mean, if you squint, this is kind of like a constellation, right? You can see the California coastline in this.
Is that what we're looking at? This is like California,
yeah.
sort of the sweep of California.
Because,
okay.
I mean, we set up a projection, but we did not tell it where we wanted it to be zoomed into, right?
Yeah.
So we're, it just I think the default for Albers is probably going to be like the United States, since it's a USA focused projection.
Okay, so if we're imagine the outline of the US here. Florida's around here somewhere. We got Texas, and here's California. Okay, but we have to imagine this right now. It's like, construct your dream palace. Could we maybe draw the states? Or at
Absolutely.
least our state, California? The one that we're in, the one that we're mapping?
Yes. And so, yes. All right. So Maya is asking really good questions, because
Absolutely.
This is exactly the next thing that will follow from us bringing in our California and drawing it, is that we'll actually be able to tell the projection, hey, I want you to zoom to California. Like, I want you to crop, as she puts it, the map so that California is in view. There's other ways which we, can leave as like further reading for folks, in terms of, like, you can center the projection on a point and then set the scale, like how zoomed in it is, stuff like that. But I think, yeah, it would be nice for us to
center it here, and like, so we can just see this area. Okay.
Yeah,
so that's one thing we could do. Sorry, instead.
And even, well, we could, the lat long I pasted in is San Francisco. We could try this real quick.
Let me capture this.
As because if you do, so when we define projection and you do d3.geo_albers_usa, you could do .center and pass in SF. And I think that would center the map so that, like, SF points would show up in the middle.
Like this? Okay, let's try. Oh, no, it says it's not a function. Did I do this wrong?
Oh, wait, maybe Albers doesn't have the center one. So some of the projections are different. Can you switch it to Mercator really quickly?
There we go. Okay, so some of the projection functions have different. Okay, so now our data is right here. We still can't see like where exactly we are, but
yeah. So maybe the best thing would be to draw California, because that gives us like a context and a place, way to orient ourselves.
Yeah. Okay.
And then
So
we can play with the projections a little bit more.
Cool. Okay. So let's draw California. How do we do that? So in order to do that, I'm guessing that we're going to need something that tells us, like, the geographic entity of California and where it is.
That is correct.
As so probably some kind of path, I'm guessing, like a border.
Yeah, there is.
Okay.
I think. Yeah, I mean, so there's a U.S. Atlas, which is a package I believe Mike Bostock made or put together, that we can require essentially into the notebook, like import it. Okay. That will give us the data we want. And so I think you have a tab open, like making a county map.
Yep. So this is another notebook of yours that, of course, is reloading.
Yeah, this notebook is something I put together because I've made, and keep making these maps, trying to document the steps
Right.
clearly,
Okay.
and so that we can reference it back. So
Okay. So this is cool. Okay. So this is that whole. Is this that
yeah, this
same
is
project? Basically, this is the thing we were imagining before when we just saw some dots over here.
yeah, and this is
Okay.
definitely a lot more than we need in terms of what it's doing. But we can just pull out right there. There's a cell US equals. That's essentially what I want us to pull in, because
Cool.
it's gonna have the boundaries, the state boundaries. It also has counties, which we won't
So maybe more than
necessarily
we
get
need.
into
We
this
don't.
time,
Yeah, but we could theoretically.
but we could pull stuff out of it. Yeah.
Okay. So shall we just use our observable magic here and import this?
I would recommend this time that we copy paste it,
Okay.
just because I think the notebook we're building now will serve as a pretty good like from scratch starting point for folks. I think
So
that
just to show exactly where it's coming from.
yeah, exactly.
Okay, so now we've got US, and let's just take a look at this. So we've got a bounding box of where it is. We've got some objects in here, counties, states, nation, and each of those is a collection of so-called geometries, which are basically really fancy polygons with lots of
Yeah, exactly.
interesting points. Okay.
It's a GeoJSON, or actually, I believe this is Topo JSON.
Topo JSON. Okay, yeah, cool.
Topo JSON.
Topo
Yeah.
JSON. I don't know how it's pronounced. Whatever.
I think, and so we can use Topo JSON library to, we'll just call one function of process to pull out the states and get them ready for mapping with D3.
Okay, great. Want to walk me through it?
Yeah. So that one line, I never memorize it, but it's the next line in the Making a County Map notebook that we were just looking at.
Gotcha. So it's this one. Oh, this. Okay,
yeah.
so where's
we just basically, we should copy paste that, and then we can require Topo JSON client. Let me show you.
Okay. So we're going to copy this part. But we probably want to change this to be...
Yeah.
All right, let's copy this and then go back in here. Okay. Let's call this state shapes instead. And then here I'm going to do US objects. States was one of the options in my objects, right? Yes, counties, states. Okay, cool. Now this would work if only I had a Topo JSON to give it. Okay, so Topo JSON or Topo, or I don't know. We can debate that as well. Added to our long list of names to debate. This is, I'm going to require, is it called Topo JSON?
Dash client.
Client. Okay, and this is basically a little utility that lets me think about this particular structure of geographic data called Topo JSON. Okay, cool. Cool.
Yeah,
so
Well, when we call topo.json.feature there, it's basically returning GeoJSON, which is like the sort of industry standard for representing geographic data, like
Okay, so this is So now what we're looking at is GeoJSON, where we get these feature collections, which are made up of features, and under the hood, it's still the same kind of basic concept, but just a slightly different format. Cool. Okay, cool. So what we've done, just to recap for my own sanity, is we have pulled some data of US boundaries, which is helpfully on the internet. And that gives us Topo JSON, which then we've used the Topo JSON client to convert to GeoJSON, where we're just pulling out the only part of this that we care about, which is that the state outlines. And now we need to get the one particular state that we're interested in, right?
Yes. Well, what we could do is we could render the whole US if we wanted to see something.
Sure.
But we could also, yeah, we could also just grab California out if you want to just render California.
Why don't we do both? Why don't we try to draw the states and then we'll try to get California. But before we jump into that, there's a couple questions in the chat. So Hero Proto asks if there's atlases for other countries.
I believe people have put together some. I'm not sure if they're distributed in the same way, like as an NPM package, but I mean, I've definitely seen many D3 maps go by with, well, even there's apparently some pretty bad fires in Argentina as well. And so I was able to like remix a map I made on fire satellite data with an Argentinian equivalent of like their state boundaries. And
gotcha. Cool. Okay. Well, so, if folks want to, kind of do their own searching while we're going here, and maybe if you find any useful libraries like this for other countries, feel free to drop the links in the chat so everybody can see, and then we can also, as folks fork this notebook and whatnot, they can change up the data sources. Okay. Great questions. Let's try to draw any country. In this case, we've got the U.S. Let's try to draw it.
all right. One thing.
Yeah.
Should we just quickly hit publish so that folks can, like, I think
sure. Yes. I haven't published in a while, so let's republish here. So folks can try their hand at drawing out our map along with us. Great. Okay, Mutari shared some Wikidata resources. That's awesome. Thanks. Nice. Okay, how do I draw this GeoJSON that I got, this state shapes?
Yeah, so actually it's even simpler than the circles in a way, because there's a D3 geopath function that essentially will let us, that will do all the rendering for us so instead of a circle, we need to create path elements.
Okay, so is this going to still be like a select all path?
That's right.
Okay.
Yeah. And the data will be state shapes.features.
Okay, because that is just how GeoJSON is structured. We want this array of features. Okay.
Yeah.
Cool.
And actually, you know what? I think we don't even need to do dot features. I think let's try it without that first.
Oh, we'll find out.
Because I think that, D3 geopath actually will handle a feature collection as well.
Oh, so then instead of doing a join, am I using a special geopath thing?
Oh no, sorry. It's still going to return a path that we're just going to set an attribute that will call this GeoUtility function from D3. So the attribute we care about is just called D. So this is like an SVG thing where like you have a path tag and a D attribute, and that attribute is like a string of numbers and letters that describes like how to draw a line.
Okay. So this is like sort of turtle programming, like draw
exactly
this far in this direction and then turn and draw more. Okay.
And basically D3 Geo is doing a bunch of like all the hard work of saying like using the projection and figuring out how to turn this GeoJSON into a series of XY coordinates in this weird format.
Okay, so that's where I'm going to call D3 geopath on. Yeah.
Well, yeah. So this is kind of a strange setup a little bit. We could even we could create a path function where you'd say path equals D3 geo.path and give it a projection, like maybe in another cell.
Okay.
Because that is, it's another one of these like generator things.
I'm just going to do this for now, but I don't know why I'm guessing this is going to be a function too, so.
Yes.
We're going to replace that in a second, but just so it doesn't complain at me about syntax. All right, and so now this is going to be path is, oops, wrong thing copied. It was D3 geopath projection.
You pass the projection in. And so that's basically going to do all the work. So now if we, in our D attribute, we want to call path and pass in D.
And here, so this is where naming gets, so here D is the D attribute of a path, which is a special like draw thing, or I don't know what D stands for. But in this one, the D stands for like a feature from these state shapes, yeah?
Mm-hmm.
I'm actually can I change it to F just to not confuse myself? Okay. Okay, cool. Is that, and then do we need to like add a stroke thing?
Yeah, typically I'd probably have a stroke, and then I'd set the fill to none.
Is that a style or an
It can actually be either, confusingly enough.
Okay, so
yeah.
stroke would be, I don't know, green?
Like gray or black or green, yeah.
Green's more fun. And then, sorry, what was it? A fill?
Yeah. You can just set it to none.
Like that?
Like
You're telling me
that.
if I
Or-
scroll down, I should see a map right now?
I hope so, yeah.
Oh. Am I not returning something right?
Well, let's see. We can,
Oh, maybe we did need that features.
yeah, let's try it without features.
Okay. We did it! We drew something! Yay! Yay! Okay, and now we're getting into, which again I'm sure relates to what Maya was talking or asking about earlier. It's a little cut off on the bottom because our height is just like arbitrarily chosen.
Yeah. Yeah, so I mean, this is perfect. We can add, there's a handy configuration for the projection. It's called fit extent. Or no, fit size.
This is in the projection function?
Yeah, where we set up our projection. So if you add, instead of doing like the center thing we were doing before, if you say dot fit size and you
Like
pass
that?
it, yeah, first you pass it an array that's width comma height.
Okay.
And then you pass it a GeoJSON object, which in our case could be state shapes. And it's just going to figure out how to make these two things fit together.
Wow. Okay. All right. So that's going to be some magic. Look at that.
Yay.
Okay, awesome. So it sounds like this fit size thing, that might be useful for Maya's question earlier about how to kind of make sure that it's within a certain
Yes.
XY range on the page. Like that's where, this is how it knows to calculate between the width and the height that we want and the extent of the geometry, the geographic features that we're passing in. That's how it's going to fit. Okay.
Exactly.
Yo, that's super cool. As folks are pointing out on the on the screen, we've made Maya yell at the fit size function. This is it. This is the magic. Magically
nice.
fits map to size. Okay.
If we really want to hammer it home, I think we could filter. We could zoom into California, since that's also, you know, what our data is in.
Yeah, let's do it. Let's woo, we've made Maya's Tuesday. Yay, this is awesome. Okay, so we're like 2 minutes over our hour here, but I have plenty of time to keep going. Are you cool to keep going, Ian?
I think we're pretty, you know, now that we got everything set up and we do a little bit more, like it's gonna be really fun to get the time.
Yeah, well, I want to see our data too. Okay, so let's narrow this down to California. In that case, can I just give it, should we make a new California object or?
Yeah, I think that's cool.
How do we pull California out of the state shapes? Are we gonna have to like filter or?
Yeah, I think probably the quickest way would be to filter the features. And we can look at the property of each feature to see the name, if the name matches California.
Okay, so f dot name, or does it have to do f dot properties dot name?
F dot properties. Yeah.
Let's just look at one of these. So Arizona, we have features. It's in this array of features. We've got a properties object, and that has a name property. Okay, cool. So f dot properties dot name equals California. And then we're probably going to have to take that out of the array, I'm guessing. Like that'll return, this filter will return an array. Let's see if that worked. Name is California. And yeah, I can tell you from just looking at these coordinates that this is obviously California. I have no idea. But we'll go with this part. This tells us it's California. Cool. Okay, so now you're saying that I could just change what I'm doing here, and I no longer need the dot features because California is a feature. And as long as I do this fit size thing to California, it's going to magically work?
Yeah.
Oh, okay, but it didn't draw this time. Oh, did I not? Do I need to do California dot geometry?
Oh, you need to pass it in as an array. Sorry.
So oh, so maybe I didn't want this. I don't want to take this out. Does that work now? Oh, now it says projection doesn't work.
Oh, well,
oh, because now I passed it in. Computers. Ah, it worked. Nice. Yay. It worked. Cool. Okay, so now we know how to like automatically resize the map with this magical fit size function on the projection. Okay, I'm going to republish this so folks can see.
And
all right.
Hero had a question in the chat, so pretty cool. So I just need to find create Topo JSON for maps I want to draw. I'd say basically yeah, but also you can find GeoJSON. Like Topo JSON is a kind of like a way to compress GeoJSON and save space and do some other nice things. But the ultimate thing that you want is actually GeoJSON. So even if you have a Topo JSON, you can turn it into GeoJSON and render it like we did.
Cool. So as long as you have some kind of structured geographic data around either in our case, like California itself was a geometry with like a whole bunch of like a polygon drawn between all of these different coordinates. But then our data here is like individual points, just like lat long points. So if you can get those lat long points and you can get the reference data for whatever base map you need, like the state or the country or the region or the city that you're trying to map things onto, then you should be able to do it with V3.
Yep.
Cool. Ah, yes, and Curran helpfully points out that if you're using shape files, which I believe is that Esri's format, is another format for this, you can also convert between those. So like there's tools out there to convert between all of these different formats.
Yeah.
All of the different format wars in the mapping world. Yeah.
Well, I'll point out that like a lot of government agencies publish in shape files. Like Esri is a pretty industry standard, yeah, a lot of people use shapefiles, so that's a common thing to need.
Awesome. All right, cool. Thank you so much for sharing that and for bringing up all these questions, everybody. Look at this. It's like pair programming times a million. It's so fun. Okay, so now can we dig into this air quality data and see how far we can get in the next, I don't know, few minutes?
Let's do it.
Okay.
So, yeah. How should we do it?
How should we do this? So what we've got right now is we had just taken, and I'm wondering, I kind of want to reorganize this a little bit. Can I maybe I want to bring this map further up to the top. Will that be confusing? No, we probably want to stick close to this render function. Never mind. All right. So I'm going to collapse some things. I'm going to unpin some cells to save us some vertical space. And I think that when we were mapping this right now, we just arbitrarily took like the first 1,000 data points here, right? Could we like select a particular subset of the points that correspond to a certain hour in the time, for example?
Yes. So the way I'd probably go about that is using another handy D3 function called D3 group, which basically all you have to do is pass it the hex data, and then we pass an accessor function to tell it what key we want to group by. So
Is that
if we
going to be
want
like this? Like a
yeah,
data
so if
point goes to...
d.day, what it's going to do is give us back a map where every key is a timestamp, and the value for each of those keys is a list of data points that we care about, or that match that key.
Okay, so like this first one here has 480, and the rest of these have like 1,000-ish. So it seems like one of those would be like a reasonable size for us to work with here. Shall I call this grouped data?
Yeah.
Just for reference.
And the next thing I like to do is grab the keys from my group. So you could do group data.keys. Oh, you might have to do array.from around that to turn it into an array.
Cool. Can I also use, does that also work in the little spread syntax, just out of curiosity? Does that work? Yeah, no, cool.
If it does, okay. It's nice, yeah.
Nice. So, JavaScript, getting fancier and fancier.
Yeah.
Well, I guess that's a little old now, but still. Cool, okay.
Yeah. So we could take one of those times out of this, you know, I'd probably save this as an array as well, or as a named cell.
Times, maybe?
Yeah.
Okay. And so we could do like times 0 and get one of the, okay.
Exactly. And so then what you can do is say hexdata.get and pass it, you know, times 0 or something, and that will give you the value at that time.
Okay, and that .get, that says, oh no, sorry, it's group data. My bad.
Oh, right, that's right.
Okay, group data.get, that's because it's a map. We have that get function. Okay, and that gives us the 480 things there. Okay, cool.
Yeah.
So,
and we can leverage Observable and save that as a thing, and then if we pass that into our chart, or you know, like when we called previously, we're slicing hex data, we can just
change this to time data. Time data. And whoa, look at that. A lot more points because they're not just randomly selected and stacked on top of each other. Okay, cool. So now we've got a particular point in time. These are all the sensors. This is pretty sweet. We see it now. It sort of fits. Some of them are a little bit off of the chart. I wonder if we want to do something about that.
I think it's okay. I mean, the nature of these sensors is like, they're not limited to California. It's just
okay.
It grabbed stuff. So
gotcha.
So yeah, I think another thing, if we change the size of the circles temporarily, like some of the, because basically we're a little zoomed out for this this data.
So we make them a little smaller. Really. Like that? Is that what you had in mind?
Yeah.
Okay, so I just, all I did was change the R attribute to a little bit smaller so we can see kind of a little bit more about where these clusters are. Cool. Now,
and yeah.
Well, so if we bring this, let me bring it back up a tiny bit. Right now, we're getting, the information that we're getting is where do we have a sensor at this particular time, right? That's like the info that I'm seeing here.
Yeah, well, and
like there was a sensor reading here, there was a sensor reading here, there was a sensor reading there.
Yeah, at this hour, I mean, and
at this hour,
each dot, it also represents sort of the median sensor value. So like there could have been many sensors within one of those dots.
Right, sorry, these are hex binned. So this is like within a particular region, this is what we're getting. Okay. So they shouldn't be overlapping. So the fact that they look overlapping is just an artifact of how zoomed out we are?
That's right.
Okay. Now, can we start to visualize? So right now we're just visualizing like where these hex bins are and that we have information in a particular hex bin at a particular time. Can we try to also visualize like what information we're getting, like what the air quality is? Would that seems like a helpful thing for an air quality map?
Yeah, I think that'd be a great call. So I basically set up the color scale previously. So we might just want to copy that out of another one.
Copy a color scale out of this one, maybe?
Yeah, because
this right here.
Yeah. Well, that's the legend. So the color
Okay, but the
PM1,
color
that's the
PM1.
function
I'm going to
that we want.
Control
Yeah.
J to jump to wherever that cell is. And it took me down here. Okay.
Yeah. So that was me. Like I figured out the same scale that PurpleAir is using.
Okay, but this could be whatever colors I want. Like if I want, I don't know.
Yeah, I mean D3 has
Like to
like
do
a bunch
from
of.
whatever color scale I want. Okay, I'm just going to copy paste this. Again, just for transparency of what's happening in this notebook. Let me put this right here. So this is our PM1 colors, which again, we have that PM1 and PM03. So but for today, we're just going to focus on PM1. So now I've got a scale which goes from the domain of values to a range of colors. And D3 will just like interpolate for me between them.
Exactly.
That's pretty cool.
Yeah. We just want to set a fill property on our circles.
So if I do like another attribute here, fill, or is it a style?
It can be either one.
It can be either. Okay, right. I just asked that before.
Thank you, SVG spec creators.
So we want to do this function is going to take a data point, and it's going to call the color function, color PM1 on D dot data. No,
D dot PM1. I think
D dot PM1. I just don't know why it was trying to be clever there, but D dot PM1. Okay, cool. And now, oh my goodness gracious, look at this. We've got an actual depiction of just how terrifying the situation is. Great. Yeah. Wonderful. I would say this makes me happy, but unfortunately I'm thinking about what we're seeing and it doesn't make me so happy. And now I'm wishing that the state wasn't green. I made it green before, but let me make it gray like you said in the first place. Okay. Ta-da indeed. Folks, we have an air quality map of sorts. Nice. One thing I don't know yet is what time we're looking at.
Yes, I think that's going to be a nice thing to see. So, I mean, for starters, we can just like, I think if we turn the current time that we're looking at into a variable, or did we already? I can't remember.
Yeah, we do. We have time. Oh, no. So we don't have our own variable for which time we want. Let me do this. Is time too confusing? Current time. And we're just going to pick one out, and then we'll use this in here. Is that what you had in mind?
Exactly. And I think this is where like the observable stuff gets really fun, because yeah, well, let's try this first. So this should still render, but now current time we could render as another cell and turn it into a date.
Yeah. Can we do that? Like, can we put the date like here somewhere, or?
We can. I'm gonna suggest that we
just do it
wait
separately
with doing other annotations on the map, just because that, essentially rendering text in SVG is like, particular. I don't know. It takes more time and it doesn't pay off as much. Yeah, I think there's another fun thing we can get to.
Sure.
Which would be to do the animation through the times.
Mm-hmm.
Yeah.
Okay, but how do we convert between these seconds and like a human readable?
Yeah, I mean, for starters, I would probably just say make a new date and pass in the current time, except for that we have to multiply the current time by 1,000 because JavaScript dates expect milliseconds. Yeah.
Okay, cool. So now we have a date, but is this going to be? Are all these times like by days, or are they by, you said hours earlier?
Yeah, so if you change the index to be something else, I think you'll see like times 1 or 2 or 3.
I see.
It's showing that. I think Observable's date rendering tries to
Tries to.
If it's at 0, midnight,
Cool.
it
Can
doesn't
we do
show
like
that out.
is it to date string? To time string? There's some. There's
Yeah.
like a time string. There's like a more precise one, right? I don't know.
Yeah.
Anybody know?
There's also like a whole D3 time format.
That's not a thing.
I think if you just do toString, it'll actually have both the date.
Overthinking it. There we go. Cool. Perfect.
I mean, it's not the prettiest string.
But
at
least we know what we're dealing with. So now as we go
Yes.
back and forth between times, we can see like what time we're actually talking about. That's perfect. That's fine for me.
Yeah. And I would suggest that we move these two cells close to the map.
Yeah.
So that we can,
let's do that. Maybe should we move the map up?
Or maybe move the map up. Yeah.
Move the map up. Okay. So now we could put now we can see what this is. Current time. Unpin. What should we do next? Do you want to add a selector so it's easier to decide what time you want to see?
Yeah, I think when you change it, we see the visualization change, right?
Yes, slightly.
If you change it more
dramatically. So I'm changing, if I change it to like 20. Yeah, it's changing. So every time I'm changing this value and I'm hitting Shift Enter to run the cell, and then Observable is reactively pulling that current time value through all the stuff that I'm doing in the render function and the data selection, and then the render function of that data to update the map for me as I go.
Yeah.
But it would be nice if I didn't have to like manually change this index. Can we put a little slider on there?
Yeah. So I'm going to recommend that we grab the scrubber, which is basically a slider that also has a play button. And it's going to be super easy to use.
It's like so we're going to import this from, is this an emboss doc creation?
Yeah. It's a might.
Is it just scrubber?
Yes. And it's a capital S in the import statement.
Aha. Okay, so we can let me open up this to show where we're pulling from here. Hello. So this is I'm just going to drop this in here. This is just a utility capitalized scrubber. Yes, thank you. Oh, already beat me to it. Thanks, ASG. This is a utility that Mike has made for us, which gives us this cool little, let me zoom in here so you can see better. Gives us this cool little advancing slider thing, which we call a scrubber. Oops, zooming the wrong window. Alrighty. So now we've got that. I can do scrubber.
Yes, and basically we want to pass our array of times in.
Scrubber and array of times. So that's going to be like the keys
right.
From our times. Okay, so times. Cool. Okay, is there a way I can...
So now basically if you were to set current time to be equal to scrubber times instead of doing it manually, it's going to be exactly what we want to see.
Okay, let me pause this for a second. I'm going to first delete this. Now it's complaining, and now it's back. Oh, it says invalid date, though. Oh, because I'm trying to convert.
Oh, it's
the current time itself is probably value?
Oh, sorry. You want to do a view of current time.
Right, of course, because this is a user input element, because basically I can interact with it. So I need that observable view of keyword, which turns this cell into a special cell called a view, which has kind of this like background cell that is useful. So I no longer need this dot value, which captures the value in something that I can access as just current time. Okay, so now, oh my gosh, look at this. Y'all, look at what we've got here. We have got an animated historical air quality map that we built from scratch, sort of, using stuff Ian had come up with before. And now we can even see, like, we can go back and forth in time. And I can pause this if I want to look at a particular time. I'm going to make these smaller, or unpin these so that this looks a little, okay. So I can decide when I want to look at. I can go back to Saturday, the 22nd. I can go to just yesterday. And oh my gosh, look at this. I mean, first of all, look at just how much red is on this map. Yikes. But we drew the red, and that is cool.
Yeah.
Even if, oh, it looks like it's clearing up a little bit recently. Sort of.
Mm-hmm. Yeah, I mean, it can get really, when you're a little zoomed, because I mean, this still is rendering like a couple of thousand points in SVG. Like, there's stuff we can do to, like we said, if you use Mapbox, or if we were to do this in Canvas, you can get a more performant animation, and you can really see like sort of the smoke clouds passing
Wow.
when you're zoomed in. Yeah, it's really fascinating.
Okay. But either way, this gives us a sense of like how things are changing. Like we can see that more recently it's been a little bit more yellow than back here. It was red a lot.
Yeah. I mean, the fires have been
A
contained.
week ago. Fires are getting contained. That's great. That's what we need. And we need no more dry lightning storms. Wow. Okay. I mean, all right, let's publish this so that folks can see. And I don't know if folks have been following along in their own forks. We have republished this now. So I'm just going to drop the link to the notebook one more time. This is what we've been working in. Wow. Yes. Beautiful. Horrifying. Wow. Ta-da. I mean, look at this. And so, okay, so to recap, because we've done a lot, we pulled in some data that you had pre-processed, which was a little out of scope for our discussion today, but we can talk about another time, or folks can look at your in your Ngelot notebooks. The PurpleAir Historical Data notebook has more info on that data processing.
Right. That's right. And
we took that data. We used D3GO to convert that data from lat-long values to points on an SVG. And we allowed us humans to have some reference for those points by drawing a reference geometry of the state or the country or a city or whatever we want, but in this case, a state. Drawing that on our SVG and then drawing a circle for each of our data points from one of these sensors. And we added this animated interactivity to it using this scrubber from Mike Bostock that allows us to visualize the different changes in data as we go through time, because that's how you had set up the data to be like grouped in these, or to be able to be grouped in these times. And from all of that, we have our own handmade, if you will, animated air quality map. I think that's pretty cool, as horrifying as the result of looking at it might be. I mean, right? Yeah, thank you so much for doing this with us. Thank you so much, Ian, for navigating me through this, and for doing all of this work to define this data and process it. Like, it's super valuable, I think, for those of us here to have the California data, but also for folks who are maybe interested in exploring like air quality data or similar type of data, like geographic data like this on their own. It's like really useful reference. And thank you so much. In your notebooks, you go through a lot of explanation about how you did all of this. So let me drop those one more time. And yeah, from here we could go on and we could add all kinds of stuff. We could add more, like we could add more details to the map. We could change. You've got this version that I just shared. This is actually the Mapbox one, which has a much more detailed kind of base map. This is the D3 one. And we could go on and add more kind of context to our base map here if we wanted to. Or we could add cities, as Karan was suggesting. But in any case, hopefully this gives folks a real solid starting point. So thank you so much for doing all that work to prepare this data and whatnot. And hopefully we can get into that on a future stream on how you did that, because I think that's a totally fascinating topic too.
Absolutely.
Yeah.
Anytime. And
Mhm.
well, I just want to. I noticed earlier, Corinne suggested that a Voronoi view of this would be an interesting visualization. So I want to put that out as a challenge to anyone who wants to fork this. I think it's relatively straightforward to adapt existing Voronoi examples to this visualization. So if anyone wants to try that and like tweet it at us, it'd be super cool to see.
Interesting. So like instead
Yeah.
of grouping the data by like or grouping the data by those like Voronoi sections instead of all of these little dots that we've got here, that would be super cool to see.
Yeah, it would. Yeah, it would show essentially as like these kind of grid cells where there's no like the dots. Well, anyway, I'm putting it out as a challenge because I think
Yes.
that there's folks who like after doing this, the next step of adding a Voronoi layer would be like pretty like I don't want to say like run in the mill D3, but like there's some examples that you could probably only take a few lines of code
Tweak,
to make
yeah.
this. Yeah,
So maybe
and
have a browse through the gallery and get some Voronoi inspiration.
yeah, like there's the World Airports Voronoi, which is probably
This
where I
one,
would
right?
start as
This
a
U.S. airports, world airports. Maybe
yeah, or the
U.S.
US one. Yeah, yeah.
Yeah. Cool. Okay.
Give a
So,
sense.
all right, challenge to our Twitch family here. If you come up with anything, please share it with us. You can tweet at us at Observable HQ on Twitter or at Engelat, it's Ian, or at Anjana Vakil is me. Let us know what you make if you go on and make your own version of this. Absolutely. Please do. Or if you do anything else, if you folks were suggesting it would be cool to see also damage, not just the air quality, the air pollution basically, but damage from the fires would be certainly valuable for folks to visualize. And like there's so many other things one could do. We talked about mapping in other regions of the world. I don't know what PurpleAir provides in terms of air quality data, but I know there's some other APIs out there that have like worldwide air quality information. So maybe folks want to internationalize this a little bit. All kinds of stuff y'all could do. Really want to see whatever you come up with, so please share it with us. And yeah, thank you so much for being with us, everybody, and for all of the amazing questions and helpful links and just making this a really productive chat and a really productive session. Thank you so much. Team effort, you know?
Yeah.
Team effort. Cool. All right. So folks can follow along. Angelat also is a stream on Twitter. When are you streaming next, Ian?
Probably this Sunday, Sunday evening.
Awesome.
California time. Yeah.
Awesome. So folks can follow Engelat and stay tuned for that. And also remember to stay tuned for more observable streams. We're going to be doing this more and more. So keep your eyes peeled for new streams coming out and more topics. We're going to be talking about D3. We're going to be talking about other stuff not related to D3. Mapping, hopefully we'll get more into. Maybe we can come back and check out that Mapbox map sometime in the future. So lots of good stuff for us to talk about. Really excited to keep this going. Yeah.
Yeah. Speaking of that, we're working on a D3 V6 stream with Philippe, who did a lot of that stuff. So as soon as we have the details ready, you can tune in here again to walk through like the changes in D3 version 6.
Awesome. Yeah. So V6 just dropped last week, right? Right before our meetup. And if you missed our D3 meetup last week, we are going to have the recording posted on our YouTube channel. So you can click through. You can find our YouTube channel. It's YouTube/Observable HQ. You can find. You'll be able to find that video coming up soon there. If you missed that, the recording will be posted. One other thing folks might be curious to participate in is that we have a survey currently out, right? To find out about how folks are using D3 and kind of how they're engaged with D3 and things they'd like to see and why they use D3 and whatnot, right, Ian?
That's right. Yeah.
Okay, let me so that's in a Google form. Let me drop this. Thanks, Wayne. That's our YouTube channel, and our D3 survey, just going to drop right here, is in this Google form. So survey. And yeah, if folks want to fill that out, whether you're just getting started with D3 through these streams or whether you're like D3 Pro who can't understand why I keep typing things wrong. No, just kidding. Please give us your feedback. We would love to know how you think about D3. So that's a lot of cool stuff we have to work on. We have our own maps to build, possibly Voronoi, possibly International, possibly whatever else. We have some new D3 streams coming up, including with Philippe from the D3 project next week. And we have Angelot streams where you do a lot of D3 work on your own stream. So tons of stuff if you want to do more D3 things. Tons of stuff to do. Alrighty, well, I think that is it for us. Thank you so much, Ian, for the extra time. It took us a little while, but we got there and we got to this amazing animated map, and I am super proud of us. And I hope that these dots keep getting greener and greener. And yeah, thank you so much again, everybody, for being here with us. We will see you next time.
Yeah, thank you.
Take care, everybody. And if you are in California or somewhere else with bad air quality like we have here, make sure you're wearing those masks and using an air filter if you can. I know folks have heard my air filter running in the background here, but please stay safe out there and be well. And we will see you next time.